Hi, welcome back to the machine learning tutorials. In this video, we are going to talk about how to split the data and how to use the machine learning models, how to train the model, how to make our first predictions, and let's save the model and also let's load back the model. If you haven't watched my first video, I would suggest you to go watch this one because this video is an extension to my first video. Thank you. Okay, let's see. Let's go back to this one, and I will quickly import all the data over here, right? So import pandas as pd, right? And so here is the file. So I'm marking it as df is equal to pd dot read csv. If in case if you have excel file, you can mention like read excel for this one csv. So this one, so low memory is equal to false. Note that this will not work for if you have excel file, so I always suggest you to go with the csv files, right? So df.head. So in our first video we already did analysis like how to check if there are any blank values and how to know the data types. um, so just go ahead and watch that one. So df.info, just to quickly look, and you can see all the data types are either integer floats, which is good. So we have like 11 we have how many so if I look at the df.shape, you can see that we have 1025 rows and 14 columns, and all from age until like thal. These are the input features or input columns, and the target is the label or the output. In the machine learn technologies, if you want to call the inputs, you can call it as a features, and the output they call it as a label. Just remember that one. So this is good. So so now if you look at this one, so we have most like two kind of ml models, right? Ml models. So the first one is the classification, second one is the regression. How we would know which one we have to use? So look at this one. The values over here, the target values are like 0, 1, etc. So if you have the output values are like this, then you have to go with the classification. If in case if you're predicting the price of a car or the prices of a flat rent, then it is a regression. And also you can use this technique, for example. So df dot target dot value counts. This basically helps us to understand. See, the output here is 1. How many ones are there? Which is 526. How many zeros are 499? This is good. You can also write the same here in a different way. Brackets target dot value count. This also gives the same results, right? Okay. Now let's start with our. So we already have the data set. Let's split the data. So why we have to split the data? In the real world, I really don't have to split the data. I can just start developing a model using the real time data, and then I will start testing my model whether it is predicting correctly or not using the new test data. And here for this demo, whatever the data set that I do have, I'm going to split the data into two data sets. One set I'm going to use for to train my ML model. The second one, I'm going to use the second data set to test the model. So for that, we have a library called train test split. So I'm importing that. Import train test split, right? And also I'm importing this numpy module as np, right? Np dot random dot seed 42. If you also put this statement, basically whatever the way the split is going to happen, the same for me, the same will happen for you as well, so that we will get same number of metrics when you are also doing the analysis. And so I'm going to split into x train, x test. So y train, y test, right, is equal to train test split. So, and before that, we have the data set, right? Let's see, we have the data set like this, and let's separate the features and let's separate the target. So, what we can do, x is equal to, you can see, instead of writing 1 2 3 all of these columns, what I'm going to drop this column for the x. Df dot drop columns is equal to target axis is equal to 1. Y axis is equal to 1 because I'm completely dropping this column. So y is equal to df. Now I just want this target column over here. This is good, and I'm gonna do like one. So this is done. Let's see the first two records of the x. You can see that there is no target value over here, target column. And let's see the y first two ones. It only has the y, the targets. So now here, coming back to this train test split, x comma y. So this is the data and test size. So I'm going to split the data into two data sets, as I told earlier. So one data set, I'm going to take 80% of the data, and the other data set, I'm going to consider only 20% of the data. So 80% of the data I'm going to feed to the ML model, and 20% I will use for the test. And also you can use random state is equal to 42. Either you can use the random set is equal to 42, or you can use np random seed is equal to 42. If you're dealing with the classification, you can use the stratify is equal to yes. Basically it helps us to split the data evenly, right? Let's execute this one. Sorry, stratify. Yep. Okay, this is done. Let's see the shape of the data. Y train dot shape. So how many 820 rows it's split into one data set. And let's look at the test data. Y test dot shape. How many? Okay, 205. So our length of the total df is 1025. And how it split? 820 plus 205. Let's see. Yes, this is matching, so this is totally fine. And then let's see the x train data. Okay, and x test data as well, in case if you want to know. You can see the index actually. So basically index are the unique values over here. So so this is done. Let's deploy our first ml model. Ml model. So I'm going to use from sklearn.ensemble. Let's use the random forest classifier, right? This is the always preferred method in this is one of the preferred methods, and there is one more method, um like reach lasso linear regression as well. So instead of writing this again and again, I'm just going to make it as like random forest is equal to random forest classifier. So n estimators, this is a default value. I'm just writing it over here. But even whether you put this function, this value over here, not, but default it is like n estimator is equal to 100 rf. And you can see our model. Okay, now let's fit the data. So we have the train data, right? So basically what we have training data. So give it as an input to the ml model, and we have test data. Test the ml model using this test data, right? So training data, so what I'm going to do, rf, which is our model, dot fit xtrain comma y train. This is good. If in case if you have a huge data set, if you'd like to know how much time it is taking, so you can use the magic method over here. Just now you can see it just took like 215 milliseconds. This is one of the ways. Now rf dot score, let's see, xtrain, right? And basically you don't have to do this one. Most of the times you do get like 100%, because what we are going to do is that we are trying to predict, we are going to check the accuracy of the model. But the training data, we just fed the data into the to the ml model, so obviously the accuracy is like 100%. Let's look at the test data, which is a new data that ml model have, which haven't seen as of now. And this is also 100. Believe me, this is like this is not a huge data set, so that's the reason it is giving 100%. But if you look at the real world problems, basically the test score would always be like around like 80 or 75, sometimes at 25. um, and then let's start doing the predictions. So we have trained the model with our train data. So I'm going to name it the vibrates is equal to rf dot predict. So basically we already have um, the test data, and also we have their values as well. So basically we are going to predict the values over here and compare with the y test values. So vibrates, so this is the prediction value for the training data, right? And let's see our actual values. This is the y test. I mean, just if you go back, you can see that the y test is from here. We split the data, right? And then if you wanna compare this one, np dot mean y preds is equal to y test. This gives 100% because we just saw the score and all. So this is how you predict the data as well. And let's see how to save this model, right? So I'm using a pickle. You can also use the joblib. Both the syntax are almost like similar. Pickle dot dump. So what is the model name? RF, and open. So delete. I'm just naming it as like RF model one dot pickle. So it is like writing book, right? So we have successfully saved our model. Now just keep an eye over here. You can see the model over here. I mean, once you are done with the work, once you save the model, and whenever you come back, instead of running all the cells again, so you can just load the model. So copy this one. So how to load this one? um, Load the model. It's very easy. For example, loaded model is equal to pickle dot load. This time open whatever it is, and then it's a read book this time. So let's see. The model is loaded. If in case if you want to predict the score, x test, y test, that's it. As simple as that. Thank you for watching. Keep watching my rest of the videos as well to know the other functionalities of classification model. Thank you. I wish you all the best.